I'll take the silence as a yes.
Yes, we can see it.
Okay, so this is something that might seem a little bit counterintuitive. If I were to ask you, how long do you take to create a VLAN on a standalone Nexus switch? The answer would be a couple of seconds. If I were to ask you how long you take to set up an interface on that Nexus switch, you'd also answer a couple of seconds, right? Maybe a minute. You go to interface, switch remote, access a trunk, define VLAN, maybe some spanning tree settings, and basically you're done, right? Those steps in ACI will take significantly more time than just a couple of seconds. I would say that once you know what you're doing, sorry, once you know what you're doing to set up the interfaces initially, I would argue it's going to take you between 5 to 10 minutes. So the question is, why do we do it that way in ACI? Why ACI takes so much longer to set up the configuration than I would have on Nexus? The reason for that is when you're doing the first config on ACI, you are creating the building blocks. And those building blocks you create get reused in ACI. So the first time you do it is going to take you a couple of minutes. But once you have that set up, now say that you want to create a new VLAN, and say you have not one Nexus switch you need to connect to, you have maybe 20 or 30 Nexus switches you need to connect to. And you need the VLAN to be present in all of those switches. So you need to go create the VLAN in each one of those switches. You need to create, pass the VLAN through a trunks. You might need to set up some other settings. And that process that took you a couple of seconds in one specific box could take you a couple of hours in a large environment. In ACI, once you have the building blocks set up, if you need to create a new VLAN or you need to have that VLAN present as a trunk in multiple links, it's going to take you a couple of seconds. So it's kind of a flip model with ACI. You're going to see that you put more work up front because you need to create those building blocks. But once the building blocks are created, if you need to push a VLAN to one switch or to 20 switches, it's going to take you a couple of seconds regardless, right? So I just wanted to give you that heads up because as I've discussed the config now, you're going to see that those are a lot of steps that you create, right? So I'm just going to go through the steps now, and then we're going to explain what every step is doing. So for this to work, we need to create a physical domain or a BMM domain. Right? So basically, we need to create a domain. We need to create a VLAN pool. We need to create an AEP. We need to create a policy group. Then we need to create an interface profile. The profile is going to have a selector. Then we need to create a switch profile. So those are the building blocks, or those are the definitions I need to make to be able to stand up interface 1/1 on switch 1, for example, and have VLAN 10 present there. I would need to create all these containers or all these building blocks in order to achieve that. Okay. So let's start with the physical domain or the BMM domain. The physical domain is basically a container for two entities, which are these two entities we have here. So an AP and a VLAN pool are contained on the physical domain. Okay? A VLAN pool is going to be a range of VLANs you define. And you're saying that any VLAN within that range could be used on the interface you're going to be creating. Okay? Then you're going to have a definition of an AP. It's an attachable entity profile. An AP, an AP basically is how you define a VLAN on an interface. It's actually a great interview question. If you read online the definition of an AP, it's a very convoluted explanation, but what the AP is actually doing is it's linking the VLANs you define as a range to the policy group. That's a definition of an interface. Once we have the AP and the VLAN pool, we create the entity that's called a policy group. And the policy group is a definition of an interface. It's a definition in abstract. Like if you were thinking from a programmatic way, what settings do I have on an interface? Right? On the interface, I'm going to have the speed. I'm going to say if it's if I want to have CDP or if I want to have LLDP. I can define if it's a port channel. I can define VLAN, right? So all the definitions, all the configuration that you could do on an interface on a Nexus switch, those are going to be done inside the policy group in ACI. The main difference you're going to see between the policy group and how we did in Nexus, the policy group, you create the policy group, right? So you don't go to a specific interface as I would do in traditional Nexus, and I would go to interface 1/1 or 1/whatever and do the config. In ACI, you create that config in an abstract, right? You say, this is the definition of what my interface would look like. Then you're going to create an interface profile. And within the profile, you're going to have the selector, which basically defines the number interface, right? So I could say this is interface 1/1. And you're going to link the selector with the policy group. So you create the definition of an interface. Then you go to create an interface profile. You create the selector. And on the selector, you actually define what number interface you want that config to apply to. And the last step in this is I said this is interface 1/1, but I don't know in which specific switch I want to apply that 1/1. I could have an ACI Fabric that has 100 leaf switches, right? So that's going to be defined on the switch profile. On the switch profile, you're going to define the pair of switches, right? So I could say this is going to be leaf 101, for example. And on the switch profile, I'm going to apply the interface profile. Basically, in this simple example, what we're saying is I'm going to create the definition for 101. And then I'm going to say that on switch 101, on interface 1/1, I'm going to get whatever configuration was defined in that policy group. Okay? So that's conceptually what we're doing with interfaces. This is something that once you do it a couple of times, it's going to be very intuitive. You just need to memorize the steps as you start. It's just a matter of repetition. You know that the first time you're bringing up a fabric, you're going to create the physical domain, you're going to create the VLAN pool, you're going to create the AP, and those are going to create poly once, and you're not going to need to have more than one. And then you're going to create the switch profile that's also going to create one. And then the only steps you're going to be doing is creating new policy groups and creating interface profiles. And it's basically steps, right? So having said that, I'm going to go to a GUI and show you how we do all of this, okay? So if I come to the Fabric tab, access policies, I'm going to have the physical domains. I'm going to show you an example with the physical domain. If you were to do it with a BMM domain, conceptually for the definition of the interface is the same. You're going to see that within the BMM domain, you have some other options, and those relate specifically to the integration, in this case to VMware. Right? But from the definition of the interface, either a physical domain or a BMM domain is acting as a container for the AEP and a container for the VLAN pool. Okay. So We're going to go to access policies. I'm going to go to a physical domain. I'm going to create a physical domain. And I'm going to say this is the test physical domain. Okay. You see that for the physical domain, I don't have a lot of options for the configuration. I can define an AP. I can define a VLAN pool. And then I can define the security domain, which basically is for RBAC. But to the actual definition of an interface, those are the two options I could have inside. So we're going to create an AP. So this is the test AP. And I don't need to put any configuration into the AP. And then I'm going to create a VLAN pool. This is the test. VLAN pool. Okay. You're going to see that you have this option between dynamic allocation and static allocation. That option is only relevant if you're doing a VMM integration. So if you're doing the VMM integration, the difference between dynamic allocation and static allocation is, if you remember from the previous session, I showed you how to push the port groups from ACI into VMware. If we create the VLAN pool as a dynamic allocation, it means that when that port group is provisioned from ACI onto vCenter, ACI is going to choose a VLAN, and it's going to choose whatever VLAN is available from the NCAP block I have defined here. If I were to do static allocation instead of dynamic allocation, when you push the port group from ACI to vCenter, you need to manually define what VLAN you want that port group to use. So this option is only relevant for a VMM. If you're using a physical domain, you can use either one, and it's not going to make a difference. Okay. So I'm going to add the NCAP blocks. Okay. So I could say I want to use VLANs 100 through. Actually, I'm using this in the now, so I'll do 900 to 999. So with this part, I did the initial side of the configuration. So now I have a physical domain. If you remember, this physical domain is what we link on the endpoint group when we do the static ports. We have the physical domain. We have the VLAN pool you're using. Okay. And we have the AP, which is here. Okay. We touched briefly on this on the previous session. So the AP can be set up the way I have it here, which it's basically empty and it's a container that's going to link the VLAN pool on the physical domain to the policy group you're going to be creating. And you could also use it to map endpoint groups directly inside of the AP. So instead of you having to define static ports inside of the endpoint group, you would come here and you would specify the tenant, the application profile, the endpoint group, and the VLAN you're expecting, and you define the membership to the endpoint group this way. As we don't have the time to get into that again, but we discussed it last week. Basically, there's some benefits and drawbacks on how you do it if you map the endpoint groups based on the AP, or if you map the endpoint group based on the static ports. So it comes down a bit to personal preference on how you want to do it. Okay. So we have the first building blocks. Now the next step we had on the list was creating the policy group. So we see we have a couple of options on how to create the policy group. This is what is important to understand for policy groups, okay? If you're using an access policy group or a port channel policy group, those can be reused. Okay? So basically, you can say this is a template for a 10 gig interface, for example. This is a template for a 10 gig interface using CDP and LLDP, or this is a template for a 10 gig port channel, and those can be created once and you can reuse. However, if you create a VPC policy group, this can't be reused. The reason you can't reuse the VPCs is how VPC works within ACI. In traditional Nexus, to set up VPC, you set up the VPC domain, you have the peer link and the peer keep alive. In the new iterations, you can do a peer link and keep alive through the fabric if you're doing VXLAN UVPN. And then the basic thing is to define the membership to the VPC. You define a port channel interface, and on that port channel interface, you define the keyword VPC and a number. You have the statement VPC and a number, and that's the way the switch on one side knows what is the peer interface on the other side, because they have the same VPC number. On ACI, when you do the configuration for the VPC, there is no VPC number keyword, which basically means the name you give the VPC policy group is how ACI defines that to be a policy group. How it defines to be a VPC. So basically, that's the reason you can't reuse a VPCs. Each VPC is unique, so those are going to remain the same. Okay, so that's important to keep in mind on what can be reused or can be pre-staged and what things need to be defined manually. So there's a question. There's no access to labs. This is just a 2-hour webinar, so it's just a demo. There's no lab access. So access, port channel, VPC. The VPC override is if you want to have a template of what a VPC is and then create something that has a different specific configuration. You can create an override from the VPC interface. Breaker, if you're using breaker cables, and then for fiber channel interfaces and port channel interfaces. So just going to create a VPC interface. Okay. So if you go through these options, basically you'd see pretty much the same interfaces, the same configuration I would apply on an interface on a Nexus switch, right? Okay, policy. I want to use CDP. If I want to use LLDP. There's this MCP is something that's new to ACI. You might not be familiar. It's called Mist Cabling Protocol. We have some configuration for spanning tree. ACI doesn't take place in spanning tree. Basically, you can only define BPDU guard and BPDU filter. So keep that in mind. And that could be important to set up if you're dual homing or to prevent if you have a bunch of TCNs coming from the legacy environment. I can have the definition for a port channel interface. If you take a look at these options, though, there's one key thing that's missing here, which is a VLAN definition. And I'm creating all the config that I would do inside of an interface, but the one thing I don't have there is a VLAN number. There's no way for me to define a VLAN there. That's the reason I was saying that the APIC kind of becomes the definition of the VLAN on the policy group. Because even though there's no definition for a VLAN, there is a definition for an AEP. So basically, I can call the AEP I created before, I can call it out here on this definition of an interface. Okay. What this is actually doing is I'm saying that, take a look at the AP. The AP was linked to the physical domain, right? And the physical domain has a VLAN pool. So basically what I'm telling this definition of an interface is that this interface could use any VLAN from the range 900 to 999. Okay. You might be asking, okay, so is this interface I'm creating an access or a trunk? The way the interface is created in ACI is slightly different. You are creating this definition of the interface, and you're saying that the VLANs that could be used in this interface are that range I have inside of the VLAN pool. But I don't know if this interface is an access or a trunk yet. The moment this interface is going to become an access or a trunk is when you actually deploy something on the endpoint group. So in the endpoint group, you're going to have options to define if this is an access or a trunk, and you're going to be calling out an interface. So when you do the config on the endpoint group, that's when this interface is actually going to become access or trunk. Okay. So we have the policy group. Now the next step is create the profile. So I'm going to create a profile. Test profile. And then I'm going to create the selector. And say the selector is 1/. So I'm going to say interface 1/20 is going to get the configuration I defined on my test VPC. Okay. So you create the policy group, which is the definition. Then you create the profile, and the profile has a selector, which is the number interface, and you link that selector to the policy group. So basically I'm saying that this 1/20 is going to get the configuration I defined on the policy group here. This part takes a minute to load. So it's going to get these settings. The next step I need to go through is I have the definition of the interface, and I have which interface I want to apply this to. The next step would be to go to LISP switches, profiles, and create a profile. In this example, we have multiple different profiles that are using the same two switches. The reason you see this is because this is a lab environment, and we want everyone to have the chance to go in and create the profile. But in an actual production environment, you would not see this. With just having one profile with 101, 102, that's enough. But I'm just going to go ahead and create a new one from scratch, just so you can see the steps. Okay. So I'm going to select the leaf selectors. So let's say this is 101_102. 1_102. And here I would choose blocks. Okay. So basically I'm saying, because this is a VPC, I want the VPC pair to be switches 101 and 102. Okay. I could choose a selector from here. I'm just going to go and finish and add it manually once it's created. So have the selector. Now what I'm going to do is I'm going to associate the profile I created before. So that's the last step of the config. Basically what I'm saying is that switches 101 and 102 are going to be getting the config linked to this test profile I created. So interface switches 101, 102, interface 1/20 are going to get the configuration from the policy group. So this is what you would need to do the first time. Now, where's the benefit on this? In a production environment, probably you're only going to have one AAP. So now let's say that I need to create a new VLAN. Someone comes to you and needs to deploy a new application, and they say, hey, we need to create a new VLAN. Instead of me having to go to each one of the switches and adding a VLAN, for me to add a new VLAN, the only thing I need to do is I would come here and I would add VLAN. So that's the only thing I need to do. So now I push that VLAN 1000 through 1050 to all of the switches and all the interfaces that are using the AAP. So this is a little bit more work up front, but once you have all the entities defined, this becomes much, much easier to work with. Making changes once the environment is set up is super simple, and it makes it much easier to manage the environment. One thing to keep in mind is this. The definition of a VPC is created here. So the profile at the lift switch level defines the switches where you want to apply the config. If you try to apply a VPC config here, but you haven't defined the VPC pair here, the config is not going to work. So this is the first step you would do, and this is something you do only once. You come here, and you define the name, the ID, a policy for that domain, and then to which switches I want to apply. In this example, I only have 2 switches, so I'm not going to do it. But if you had a different pair of switches, let's say 103 and 104, that's where you would go ahead and do it. Okay. Good. So that's the theory on creating the interfaces. Once you have all set up, you would pick up on the place where we discussed in the previous session, which was with the logical constructs. So once you have that, that's when you can go into your endpoint groups and you can do the static ports, you would add the physical domain, you would actually start doing the config you do on the tenant side, okay? But all these things need to be defined beforehand. If you don't have them, then you won't be able to set up your endpoint groups properly because the interfaces will not be created. Any questions on what we just saw, on how we create interfaces and how we work with interfaces? Okay, good. So now we'll move into discussing L2 outs properly. So you could add, let me show you. If you wanted to, you can add specific VLANs, like you don't need to arrange. There you go. So I could say VLAN 2000, for example. So you can specify a single VLAN, and then if you wanted to, I could do 2001. And so on. So you can do it manually. It's going to take more time, and there's no actual benefit of defining single VLANs instead of doing a range. To be honest, because I'm a very lazy person, what I would do for this configuration is something like this. I would put something like that, where I define or I pre-stage all of the VLAN ranges, just because the definition on the VLAN pool doesn't actually mean you're creating the VLAN. It just means that the VLAN could be created if you put it on the endpoint group. So if you take a look at the CLI, if you take a look, the VLANs that got created are not the VLANs I put on the range. The VLANs that get created are the VLANs that are actually being used by an endpoint group or an L2 out. So unless you have a definition of the VLAN inside of the endpoint group or the L2 out, the VLAN doesn't actually get created, get instantiated. The VLAN pool just means that VLAN from a fabric perspective, that VLAN can be used and is expected at that interface. So it's just easier to create an all-encompassing range that you can just create once, and then down the line, if you need to create more applications, if someone asks you for something, you don't need to go back and add a VLAN to the VLAN pool. The VLAN is just there. The only thing you do is you create the endpoint group and you define the VLAN within the endpoint group. So now we have the L2 outs properly. Okay, so take a look at what we're trying to do. We have our ACI Fabric, and the Fabric is probably gonna get gonna have something like this. I'm gonna have server A here. I'm gonna have server B here. So let's say we brought up the environment. We created all the constructs inside of ACI. So we have the VLAN pool, we have the endpoint groups, we have basically all the definitions that we need to define in ACI to make this work. So once all of that is set up, the next step is probably I'm going to have to migrate to ACI. I'm going to have servers that are outside of ACI, and I need to move them into ACI. And I would say that for most clients, that's the only reason you use L2 outs. You use L2 outs during a migration process to migrate servers from outside of ACI into ACI, and you use the L2 out to consume a default gateway that's going to remain outside of ACI. Okay? So most clients, you don't really use the L2 outs once you're fully migrated. Once you migrate, you erase them. But understanding the L2 out is very important, because the L2 out is how you migrate. And so let's say I want to move this server, and I got the server and I moved it here. So I have server A here, and I have server B here, and we're going to say they're part of the same subnet. Okay. And I'm going to say this is VLAN 10 that I was using here. So the L2 out uses slightly different logic than what we had before for forwarding. We said that all the traffic within the ACI Fabric was forwarded based on the endpoint tables on the switches. The L2 out is going to follow a more traditional logic, which is the MAC address table. So the forwarding is going to be based on that MAC address table. The L2 out cares about VLANs. So we said before that on ACI, I could have a server on VLAN 10 and a server on VLAN 20, and they could both be part of the same endpoint group and have the same subnet. And that the VLAN was just a way for me to define what belongs to the endpoint group. That is true, but here, if this switch is the legacy switch here, has VLAN 10 here, and this is defined as a trunk. That means that for this to work on the ACI side, I need to define VLAN 10 on that interface. Right? Once the server is here inside of ACI, I don't really care. This could be VLAN 20 here. So that's fine. But if I'm expecting VLAN 10 here, I need to use VLAN 10 on the ACI side. That's the only place where this is very important. Is that to achieve this config, there's two things you can do. There's a proper L2 out, which you create as an L2 out, or the other option is, as I mentioned, that EPG extension or bridge domain extension, depending on how you want to call it. So let's take a quick look of how we set up an L2 out. So networking, external bridge networks. And we create the L2 out. The config for the L2 out is pretty straightforward. So the L2 out is going to consume a bridge domain. Right? So the same bridge domains we're using for endpoint groups, the bridge domain is going to be consumed by the L2 out. The bridge domain is basically the layer 2 construct that's linking the endpoint groups in ACI to the L2 out. So again, going back to our example, if this is endpoint group 1, right? Endpoint group 1 is going to be using a bridge domain, right? Let's call this PD1. So if I want server A to be able to use the L2 out, I need to have the L2 out use, sorry about that. I need to have the L2 out use the same bridge domain. So the L2 out needs to use the same bridge domain 1. So the bridge domain is the entity that's providing the link between the endpoint group and the L2 out. Okay. So we create the bridge domain. We're going to define a VLAN. We're going to have an external physical domain. The external physical domain is basically the same thing as a physical domain, but it's just created for the L2 outs. So let me show you. This is the physical domains. External bridge domains are basically the same thing as the physical domain, so they follow the same logic. In order for you to set up the L2 out, you would go through the same steps of creating the VLAN pool, the AAP, the policy groups, the interface profile, the switch profile, and so on. The only difference is that you create a specific type of domain that's called an external bridge domain, right? So unless I create something here, I'm not going to see it as an option here. So if you take a look, the only two I could use is the one I had and the one I created. It's not showing me the options for the ones I have defined as physical domains. Okay? But logically, they do the same thing. Then I need to define to which interface I want to use the L2 out. So you can define a specific port. So I would choose the node and the interface. And then you would choose the actual interface number you want to use. In my example, we're using interface 1/44. Right? I could use a port channel interface as well, or I could use a VPC interface as well. Right? So I could use any of the VPCs I created. I don't have any port channels in this environment. if I could use them. Okay. So the L2 out is pretty straightforward. The last thing you need to understand is this network. And this reads network. I'm working on code 4.0. Some of the options in the newer code, you're going to see that the names are different. But basically, this network option here means external endpoint group. So this network I created is basically an external endpoint group. And here's where I would apply the contracts. So even if this is an external endpoint group, so we have something, so even if I have server B here trying to talk to server A here, even though this is outside of ACI, I still need to have a contract in place to allow traffic from A to B or from B to A. Okay? So I need to define that, that contract. The way the contract is going to be defined is I'm going to apply it on the endpoint group for A, and I'm going to apply it on the L2 out for B. Right? And the contract is going to follow the same logic as we saw last week. So consumer is a source, provider is a destination, and you can use the options of reverse filter ports and apply both ways. Right? So the same logic is going to follow. The one thing to note is on the L2 out, I don't have a way to define multiple VLANs. I can only have one VLAN inside of the L2 out. Okay. What that means is if I have 20 VLANs I need to migrate to ACI, I will need to create 20 L2 outs. By creating 20 L2 outs, I don't mean that you will need to use 20 different physical interfaces. You can use the same physical interface. I can say this is interface 1/44, right? So the interface is going to be the same, but logically, I need to create multiple L2 outs. So if I want to use VLAN 3000 here, I would need to create a new L2 out. So I created a second L2 out. The L2 out is using the same physical interfaces as this one here, but I'm using a different VLAN number. Right? I'm getting a fault here, and basically the fault is because I don't have VLAN 3000 defined as part of that AP. So to get rid of that fault, the only thing I would need to do is come here. Here. Let me see the fault went away. So what I have defined here is I have two L2 outs. They're still using the same physical port, but they're two different entities. Okay? This is the main difference between using a proper L2 out and using an EPG extension, which is what we're going to cover different. On an EPG extension, I could potentially create multiple VLANs inside of the same endpoint group, whereas on an L2 out, you don't have that option. I can only I can only have one VLAN here. Okay. So before we get into the EPG extension or the BD extension, any questions? No questions? You're awfully quiet today. I don't know if that's good or bad. Okay. So we'll get into the other option to create the same thing, which would be doing an EPG extension. Okay. So So I'm going to create a test L2 out. I'm going to have to use a different interface just because it's not going to change all the lab. Let me think about it. Give me just a minute to do a change on the back end. Okay, good. So I'll come to the endpoint group. I'll bind it to a physical domain. And I'm going to find the static ports. So basically, what I did was recreate the same config, but now instead of using an L2 out, I'm using an endpoint group. So what's the difference? So we need to understand the traffic flow. So there was a question if you can configure a port as a trunk. Yes. The way you configure a port as a trunk is when you're doing the static ports here. When I deployed on the endpoint group, sorry. This is where you have the option of defining it as a trunk, access, or untagged. So the definition of if it's a trunk or not is not done on the Fabric tab on the definition of the interface. That actually becomes an access or trunk when you start using it on an endpoint group. Okay. So this is where you define if it's access or trunk. If you define it as access, you would not be able to use the same interface on a different endpoint group. If you use it as trunk, you could have the same interface with a different VLAN number used on a different endpoint group. Okay. So we had basically two things of applying the same config. So what does that actually mean from what I'm setting up? So we clean up this a little bit. ACI Fabric. Oh, that's the environment. So a couple of differences. So how does the traffic flow between A and B? How is the traffic actually forwarded? The way the traffic gets forwarded is, let's say A is sending traffic and he sends an ARP. Okay. In legacy networking, an ARP is a broadcast. So this switch is going to take it and he's going to send this way and he's going to send this way. Okay. That ARP coming into ACI, it's going to get flooded going into ACI. Right? Even though ACI doesn't do ARP flooding, on the L2 out, broadcast traffic gets flooded into the ACI fabric. So the forwarding logic of the traffic between A and B, consuming that L2 out, is going to leverage the MAC address table. So this switch is going to have a MAC address table, and he's going to learn MAC addresses on this L2 out here. Okay. If I were to do the same config, but now instead of using an L2 out, I define this as an EPG, or part of the EPG, as we did in the last example. Then what you're saying is that for traffic coming to this ACI leave, those are going to be part of the endpoint table. So the traffic is going to be learned on the endpoint table. Okay. You might have seen there's an option in the bridge domain, and we touched on this in previous sessions, where you can define what I want to do for flooding of the traffic. Like, do I want to flood a non-Unicast? Do I want to flood the ARP? For L2 outs, you will need to flood the ARP because you're going to have a default gateway that sits here. And if you don't enable ARP flooding, there's no way you're going to get onto this gateway. Because when he sends traffic, when he tries to ARP for the default gateway and that hits the leave, that gateway is never going to be a part of ACI's endpoint table, right? So because that's not part of the endpoint table, for him to reach this guy here, you're going to have to set up the flooding. Right? So there's two ways to set up the flooding. One way is to enable ARP flooding here and enable a non-Unicast flooding. That's one option. The other option is deselecting the Unicast routing option here. If you deselect the Unicast routing option, regardless of what settings you have defined here, the switch is going to behave as a layer 2 switch, and it's going to do flooding. So you can do both options. For migration purposes, I prefer to use this option of unchecking the Unicast routing because I can create the bridge domain. I can put whatever settings I need to have when I'm done with the migration. I can define the subnets that are going to become the default gateways on ACI, and I can do all of this configuration and leave it there. And this config is not going to get applied until I apply the Unicast routing option. So I can create the L2 out for migration purposes. I can define the subnets and the settings, and then just disable the Unicast routing. Once I'm done with the migration, the only thing I need to do, instead of recreating stuff, I click that option, hit submit, and at that point, the settings here and the settings here are going to take place. So the two main difference, one difference was how we forward traffic. One was based on the MAC address, because for the external endpoint groups, those are not being learned as part of ACI. And the other option is with this EPG extension, and at that point, those endpoints do become a part of ACI. So the logic there for the forwarding is slightly different. Where this is going to have a huge impact if you want to use L2 outs or EPG extensions is when we discuss how VLANs work, and the fact that for an endpoint group, I could have more than one VLAN defined, whereas I cannot do that for the L2 out. So let's take a look at a little bit more complex scenario, right? So I have the spine and leaves. And now let's say I'm connecting this to a legacy 7K. And then I have a different 7K here. And they're connected to one another. And now I have connected here. Okay. So let's take a look at how spanning tree works with ACI. Let's say this is a switch, and let's say this is the root for the spanning tree topology. Okay. If this is a hub, and I connect it this way, okay? Are both ports on the root bridge going to be designated ports? Are both ports on the root bridge going to be forwarding? Or is one of them going to be blocked? What do you think? So one of the first things we usually learn or we repeat is that on a root bridge, all the ports are designated ports. So all the ports are going to be forwarding on a root bridge. And that is the case in our networks most of the time because we don't have hubs anymore. Right? However, if you were to connect the root bridge to a hub, what would happen is the hub is not going to process the BPDUs. So you're going to have one BPDU coming this way, and you would have one BPDU coming this way. And basically the hub would take the one coming this way, and he would forward this way, and he would take the one coming this way, and he would forward this way. So the root bridge is going to see the two BPDUs he sent coming back to him. So he's going to understand that there is a loop in the topology, and he's going to block one of the links. Right? So even though he's a root and he's a root bridge, he could have a port that's blocking. This is important to understand that behavior because ACI takes a similar logic with spanning tree. So you're going to have one BPDU coming this way, and you're going to have one BPDU coming this way. Okay. As we said, ACI doesn't take place in the spanning tree. So ACI is not going to process spanning tree BPDUs, but the spanning tree BPDUs will get flooded within the bridge domain. Right? Send this way, and he's going to send this way. Okay. So the 7Ks are going to see that the BPDUs they're sending come back to them. So depending on who's the root and the priority in the ports, one of the links is going to be shut down by spanning tree. So if you're dual homing ACI to a legacy environment and you connect it to switches, both ports are not going to be forwarding. One of the ports is going to be in a blocking state. Obviously, you can have per VLAN spanning tree, and you could say for some VLANs, one is going to be forwarding, for some VLANs, the other is going to be forwarding. But the basic thing you need to keep in mind is ACI is behaving as a hub. ACI is not processing spanning tree VBDUs. ACI is just forwarding the spanning tree VBDUs across. Okay. So one of the things I told you was that ACI floods traffic within the bridge domain. So the traffic gets flooded within the bridge domain. That is true for most of the traffic, but not for the spanning tree traffic, not for the spanning tree VBDUs. So this is where it's important to understand how the the VLANs in ACI work. Just gonna pick an endpoint. Okay, so let's take. Okay. So I have this endpoint, and this endpoint is using VLAN 1501. Okay, and this is being used in interface for channel 14. So I'm gonna do okay. For channel 14, it's up. Okay, interface. Now, if I do a show VLAN brief, you're gonna see that there's no VLAN 1501 if I do a show VLAN brief. Take a look at, there's no option for VLAN 1501 when I do the VLAN brief. However, if I do show VLAN extended, there I'm gonna be able to find VLAN 1501. Second. Okay, there you go. So why is that? Okay. You need to understand how VLANs work in ACI. And show VLAN extended shows us a bit of it. It shows us the mapping between the ACI is using, the VLAN ACI is using, and the VLAN tag I'm receiving on the port. A better command to understand this and understand what we're going to discuss around spanning trees is so let's find our VLAN 1501. Okay, here we go. So VLAN 1501, it's an FD VLAN, and the FD VLAN is using the VLAN 20. And if we take a look at the VLAN 20, is this VLAN or this segment I have here. Okay, so the BD VLAN is a representation of the bridge domain. The FD VLAN is a representation of the endpoint group. Okay. If we take a look at the settings on the bridge domain, okay, multi-destination flooding is flooded within the bridge domain. But spanning tree VPDUs get flooded inside of the FD VLAN. Okay. Spanning tree VPDUs are forwarded based on belonging to the endpoint group. They are not flooded based on being a part of the bridge domain. why is that important? When we were talking about VXLAN, we said that there's a mapping between a VLAN and a VXLAN segment, but the traffic within the fabric gets forwarded based on the VXLAN encapsulation. Right? And we see there's a specific VXLAN encapsulation for the FD VLAN, and that encapsulation is different than the encapsulation we have for the bridge domain. Right? If take a look at, oh well, this is group 5. So we have segment 7725, which is the segment 7725 we have here. Okay. So why is it important that spanning tree VPUs get flooded within the FD VLAN with this VXLAN segment? This value that you see here, this VXLAN segment, that value is derived from a combination of the VLAN pool that you created and the actual VLAN number that you're using. Okay. So when you create the VLAN pool, that creates an object in ACI, and that object has something that's the base encap value. And with that base encap value and the actual VLAN tag you're using, ACI comes up with this VXLAN segment you're going to be using. Okay. So with that knowledge, what I could do is this. Let's forget VPUs for a minute. So let's say I'm new to ACI and I'm not sure how to create stuff. So I'm going to create a physical domain. I'll call it physical domain 1, and it's going to have VLAN pool 1, and it's going to have AP 1. And then I'm going to create physical domain 2 with VLAN pool 2 with AP 2. Okay. And I'm going to be using this one for 7K1 here. This is 7K1, this is 7K2. And I'm going to be using this one for 7K2 here. Okay. Instead of using an L2 out, I'm going to be using the VD extension or the EPG extension. So the problem is that if I do this config, and let's say I have VLAN 10 that I'm using for the L2 out, and I create VLAN 10 on this interface, and I create VLAN 10 on this interface, because VLAN 10 is using one VLAN pool, and the other interface is using a different VLAN pool, even though I'm using the same VLAN 10, that VLAN 10 inside of ACI is not going to have the same VXLAN segment. Because that VLAN 10 is what ACI calls the access encap value. The access encap VLAN, which is this VLAN tag you see here. Right? But that value is going to have different VLAN IDs. They're going to have different FD VLANs. They're going to have different VXLAN segments, but they will belong to the same bridge domain. Right? So as we see here, we can have multiple FD VLANs using the same bridge domain VLAN. Right? So if we did this, what's going to happen is if there's a spanning tree BPDU that's forwarded this way, and there's a BPDU that's forwarded this way, these BPDUs are not going to loop around. Because inside of ACI, this is going to be one FD VLAN, and this is going to be a different FD VLAN. Okay. So from a spanning tree perspective, they're not going to be forwarded. However, when you have a host connected to a 7K and that host sends a broadcast, the 7K is going to send the broadcast here, and it's going to send the broadcast here. The 7K2 is going to send the broadcast here, and the ACI Fabric will loop around the broadcast because the broadcast is forwarded based on the VD VLAN membership. So if you set up things incorrectly and you're dual homing, you can cause a spanning tree loop. Okay? This is very important to keep in mind because if you do this, you will get fired. So what's the benefit, or how can we avoid this? So this is where understanding the L2 outs and the VD VLAN comes into play. If you use an L2 out, the L2 out in ACI can only have one external physical domain and can only have one VLAN, which means even if you try to misconfigure it, you will not be able to, because the L2 out will have one endpoint group, which means the L2 out will only have one FD VLAN. And even if you use multiple interfaces, both interfaces are going to be part of the same VXLAN segment based on the FD VLAN. So if you do L2 outs, there is no option that you can misconfigure it. If you do it based on the EPG extension or the VD extension, and you don't know what you're doing, there is a potential that you could cause a loop. My suggestion is that you always use L2 outs because of this. Using the L2 out, there's no potential for you to misconfigure something. And that to me is something that's great. So I would suggest you use L2 outs when you need to connect layer 2 to ACI. Some people will recommend that you use the endpoint group extensions, that you create this as an internal endpoint group to ACI, because you can have multiple VLANs, there's potential that you can reuse that endpoint group you create and have multiple VLANs inside. Whereas with the bridge domain, with the L2 out, you will need to create one L2 out for every VLAN you need to migrate to ACI, which could be a little bit more work. And the other reason is on endpoint groups get tested more for bugs from a QA perspective than L2 outs. So that's another reason people might suggest that you use an endpoint group instead of the L2 out. I haven't hit any bugs on the L2 outs. To be honest, I've never had a problem with them. And I've had clients that misconfigured endpoint groups and created spanning tree loops. So as I said, my suggestion is that you use L2 outs for connecting layer 2 to ACI, not the endpoint group extensions. If you are going to use endpoint group extensions, my suggestion is only use one AEP and one VLAN pool on your ACI environment. Don't create multiple VLAN pools. Don't create multiple AEPs. There's no need for you to create multiple. There's specific use cases where you need to create more, which is if you're going to have overlapping VLANs or you have overlapping environments. So the rule of thumb is have one physical domain, one VLAN pool, and one AEP per production environment, unless you can think of a reason why that's not going to work. So if you're setting up the config and you're thinking, do I need to create multiple physical domains? Do I only create one? Do I need one physical domain going to one switch or to one firewall and a different one going to a different one? Just think of this. If there's a specific reason where you can think that you need to have two, like for example, if you do per port VLAN groups or per port VLANs. In that case, yes, there's a specific reason you can go ahead and create multiple. If there's not a specific reason why you need to create multiple, just stick to one. You're going to make your life much, much, much easier, and you're going to avoid a lot of headaches. So any questions on the L2 outs or the endpoint group extensions? So using an L2 out or a bridge domain extension or an endpoint group extension doesn't have much to do with the network centric or application centric. To be honest, you could do application centric and use endpoint group extensions. You can create one endpoint group for every VLAN you're migrating and do it within that migration. So it's not really part of the network centric. We're gonna have, so the next session is L3 outs. The session after that is gonna be network centric and application centric deployments. So probably when we get to that session, we're gonna have more time to discuss what that means. But you could do it one way or the other, both for network centric or application centric. It's basically how you want to create the construct. I don't know if that made sense or not. If it didn't make sense, I promise that once we get to that discussion, it's going to make more sense.